Right, we need to find what are called direction angles. A vector has direction and magnitude. We've discussed the magnitude quite thoroughly. Let's look at the direction angle. The direction angle of a unit vector u is an angle measured counterclockwise from the positive x-axis to the vector u. Since the vector is a unit vector, its terminal point lies on the circle. Therefore, u is equal to xy cosine theta sine theta, or cosine theta in the I direction plus sine theta into j. Angle theta is called the direction angle. In this diagram, u is a unit vector. Can theta be found for any vector? Consider v equals ai plus bj in standard position. Since u is equal to v over the magnitude of v, and that is equal to the cosine of theta sine, then v is the magnitude times the vector, and we can expand it into the I and j components. Since v can be written as ai plus bj and can be written as the magnitude of v times cosine theta in the I plus magnitude of v times sine theta in the j, we've got what you see there. The tangent of theta then equals the sine over the cosine. Multiply numerator and denominator by the magnitude of v and use the arctan to get the direction angle of the vectors. Now, let's try some examples to see where they can be used, those direction vectors with sines and cosines. Let's find the direction angle for v equal to 3i minus 5j. Right? I've drawn a little picture of it there. And there's our angle that we would like to find, angle theta. A is 3, B is minus 5. Basically, B is representing the sine, 3 is representing the cosine. So sine, negative, cosine, positive is quadrant 4. See the diagram over there? So we want the inverse tangent of minus 5/3, which is minus 59.04. Subtract that from 360, and so our direction angle is 300.96. If we want to find the magnitude, then the magnitude of v would be equal to, and we have the formula there, the square root of 34. All right, let's look here at some resultant forces. Three forces with magnitudes of 75, 125 pounds respectively act on an object of angles 30, 45, and 120. Find the direction and magnitude of the resultant of these forces. All right, we're going to start by finding the resultant for the 30 and 45 angles. Then we will use it with the 120. All right, so we need to find the vectors and add them. All right, how do we find the vectors and add them? Well, this is where changing it into in terms of sines and cosines will really help us. So we do the magnitude times the cosine of 30 in the I plus the sine of 30 in the j, and similarly for the 45 degrees. Okay, and we get 70.7 and 65 comma 37 point that. We add those two together, and so this is the resultant for the 30 and 40. Now we're ready to find the resultant for the 120 degree angle and the vector 135.7, 1808.2, which we found in the previous screen. So we start in with our good old direction vector here, direction angle of cosine 120. Do a little bit of work with the calculator to find the cosine and sine of 120 and multiply it by 125. And so the direction then is 73.2 and 216.5. So if we want to find the angle, then we go with the sine over cosine, b over a. So our angle is 71.3. We need to find the magnitude of that. Use your calculator. You should be very good with this by now. And so that equals 228.5.